H.C. Verma, Wave Motion and Waves on a String, Question 44. Here is the setup. A guitar wire of length 30 cm is stretched between two bridges. When no finger is placed on it, the entire wire vibrates at its fundamental frequency of 196 Hz. Watch the fundamental standing wave, 1/2 wavelength, fits along the full length. When you press your finger on the string, you create a new fixed point. This shortens the vibrating length of the string. A shorter string vibrates at a higher frequency. The wave speed remains the same because the tension and mass per unit length don't change. So the frequency is inversely proportional to the vibrating length. Here is the question. A particular guitar wire is 30 cm long and vibrates at a frequency of 196 Hz when no finger is placed on it. The next higher notes on the scale are 220 Hz, 247 Hz, 262 Hz, and 294 Hz. How far from the end of the string must the finger be placed to play these notes? The key concept is the relationship between frequency and vibrating length for a string fixed at both ends. The fundamental frequency is wave speed V divided by 2 times the length L. Since the tension and linear mass density stay the same, the wave speed V is constant. So frequency is inversely proportional to length. We can write new length L equals the original length L0 times the ratio of original frequency to new frequency. Step 1. We know the original length L0 is 30 cm and the open string frequency F0 is 196 Hz. The formula for the required vibrating length is L equals 30 times 196 divided by the desired frequency F. Let us calculate for each note. Step 2. For 220 Hz, L equals 30 times 196 over 220, which gives 26.7 cm. For 247 Hz, 30 times 196 over 247 gives 23.8 cm. For 262 Hz, 30 times 196 over 262 gives 22.4 cm. And for 294 Hz, 30 times 196 over 294 gives exactly 20.0 cm. So the finger must be placed at these distances from one end of the string. Here is a visual comparison. The orange bar is the full 30 cm string at 196 Hz. Each shorter bar shows where the finger must go for the higher note. Notice how higher frequency means shorter vibrating length. The correct answers are, for 220 Hz, the finger goes at 26.7 cm. For 247 Hz, at 23.8 cm. For 262 Hz, at 22.4 cm. And for 294 Hz, at 20.0 cm from the end of the string. Here are some important tips. Tip 1. For a string fixed at both ends, frequency is inversely proportional to vibrating length when tension is constant. Tip 2. Pressing a finger creates a new node, shortening the effective vibrating length. The wave speed stays the same. Tip 3. The formula L equals L0 times F0 over F is a quick shortcut. You don't need to calculate the wave speed separately. Tip 4. In musical instruments, each fret on a guitar is placed using this exact inverse relationship between frequency and length. Like and subscribe for more H.C. Verma solutions at MAGPIEHUB. See you in the next video.